In keyframe animation, animators often specify individual poses and time these out to approximate a motion. In common spline editors, this is represented by a collection of knots aligned in time. In final animation, these knots are moved around slightly in time to model effects like force propagation and motion asymmetry. Here, we are modeling the propagation of force outward from link to link. When we computationally model poses as a collection of values, rough animation can be represented with a sparse set of controls. For final animation, however, pose-based representations cannot represent timing variation among the knots. We would therefore have to present animators with sets of controls at many different times, and there would no longer be a single editable geometric representation of the pose. In our work, we introduce staggered poses, which explicitly represent this timing variation. This allows us to retain a sparse set of animator controls for pose-based animation that includes timing variation. Here we show two important types of timing variation used by animators, which we can represent with sparse controls in the staggered pose motion editing system. On the left, we have a simple two-pose transition. By changing the timing of different limbs, we can introduce temporal asymmetries in how different parts of the body reach coordinated extrema. On the right, we introduce succession, which models force propagation outward through each limb as well as through the trunk. After these forms of timing variation are added, the staggered pose representation allows us to retain sparse control over geometric qualities of the motion using the two original poses. To facilitate sparse, pose-based editing of dense motion data, we introduce a motion model that uses staggered poses as the foundation. On top of these, we use a combination of splines to provide low-frequency control over transitions and motion displacement maps, which allow for the representation of arbitrary movement detail. Inverse kinematics is layered on top to enforce constraints. When we display all the extreme values of a staggered pose together, in a state which we call the unstaggered pose, it appears as a slightly exaggerated version of the true pose through which the character moves. This appearance results from bringing each degree of freedom into the more extreme state represented in the knot value at the staggered time. We allow animators to edit either the unstaggered pose, which allows for coordinated direct editing of extreme values, or the true pose that the character passes through. To edit natural human motion, we introduce an algorithm that searches for coordinated motion features in local degrees of freedom. We use the timing variation among these features to model time staggering. We prioritize the staggered poses extracted from a motion using a heuristic algorithm, and we allow users to interactively select a desired set of controls using a slider. Note that our feature-based poses are visually similar to extreme poses used by animators when sketching out a pose-based motion. Here we show 3 examples of editing recorded motions, which have been converted to staggered pose representations. Here, we edit a lift and carry motion to change how the object is held and change the motion of the back to increase the apparent effort. The staggered poses are extracted and edited, and succession is then added. In this example, we exaggerate the landings and leaps of a jumping motion, and we again add procedural succession to loosen up the overall feel of the motion. In this final example, we change a walking motion by changing how the arms are held and how the back moves, and then we apply an exaggerated succession to the back and arms to stylize the movement.